Hello everyone, welcome you all to another episode of EMI Labs. In today's video, we are going to talk something about unity gain amplifiers, also known as voltage followers. It is a type of an amplifier with gain equal to 1, which is why it is called as unity gain amplifiers. In other words, this amplifier has an output voltage which is equal to input voltage. In general, the purpose of amplification or an amplifier circuit is to take a weak or a small input signal and produce an output voltage which is an increased version of the input signal. Simple. But in case of unity gain amplifiers, the output voltage of the amplifier is equal to the input voltage. Then what is the purpose of having this circuit and why does this circuit exist? In today's video, we are going to discuss about all these points, so stay tuned. Since the voltage gain of this amplifier is equal to 1, it might be possible to misunderstand that this circuit does not amplify the voltage. Instead, this circuit actually amplifies the current. Let us see if that is the right case. There are 4 major types of amplifiers based on input and output parameters. Number 1 is a voltage amplifier. A voltage amplifier sends the voltage at the input pins of the amplifier and generates an output voltage. The output of this kind of amplifiers can be modeled as a voltage source. Here comes the second type of amplifier called current amplifiers. This current amplifiers sends the amount of current passing through the input pins of the amplifier and generates an output current. The output of this type of amplifiers can be modeled as a current source. And the third type of amplifier is called transconductance amplifier, where this amplifier senses the voltage at the input pins of the amplifier and generates an output current. The output of this amplifier would be a current source and the input will be a voltage sensing. And here comes the fourth type of the amplifier called impedance amplifier. This impedance amplifier senses the amount of current flowing through the pins of the amplifier and generates a voltage out. The output of this amplifier can be modeled as a voltage source. You might have a question. What is the difference between a voltage output and a current output? Or in other words, what is the difference between a voltage source or a current source? Let me know in the comment section if you want a separate video on voltage source and current source, and I would be happy to provide you with one. Coming back to topic. This unity gain amplifier senses the voltage at the input pins and generates an output voltage which is equal to input voltage. The input and output of this amplifier is a function of voltage, not current. So definitely this is a type of voltage amplifier which amplifies voltage, but the gain is set to 1. It again puts back the same question. What is the purpose of this circuit? Why it is used? And we'll discuss in detail. Let us understand 2 terminologies. Number 1, source, and number 2 is a load. A source is a device which is capable of providing electrical energy. A load is a device which usually consumes electrical energy. Let us consider we have a 5-volt power supply. Is this a source or a load? A power supply generally provides electrical energy, so this is a source. Now I am connecting a bulb to this 5-volt power supply. Is this bulb a source or a load? A bulb is a circuit which consumes electrical energy, so this bulb is a load. So what happens when I connect a bulb to a 5-volt power supply? Let us assume this bulb is capable of operating under 5 volts. So we would expect the bulb to glow. Isn't that right? Now I am adding one more bulb to my power supply. So now I have a power supply and have 2 number of bulbs. So what do we expect to happen now? We would expect that both of these bulbs will glow. I am trying to add few more bulbs to the circuit. Not actually few more, a lot more bulbs. I am trying to add thousands and thousands of bulbs to this power supply. What do you think it will happen? Would all these bulbs glow? You need to understand that adding more load to the power supply increases the power consumption. Are we missing something? We have a 5-volt power supply and we have a load which operates at 5 volts. But we are not sure how much number of loads that this power supply can operate. I think we are missing some details. This is because the power supply is characterized only in terms of its output voltage, and it needs a few more parameters in order to completely characterize the full performance. One of the important parameters is called rated current. Rated output current is the maximum amount of current that the power supply is capable of providing. All power supply systems comes with an output voltage rating as well as a rated output current rating. Take your mobile chargers, take your laptop DC adapters, and take whatever power supplies you have. It will have an output voltage rating and an output current rating. If the current consumption of the load goes beyond the rated value of the power supply will not be capable to provide that much amount of current to the load. The output voltage, which is 5 volt, will slowly drop from 5 volt to 0 volt as you keep on increasing the load. This phenomena of dropping of output voltage when the current consumption is beyond the rated current is called overcurrent loading. In previous section we have discussed about output current loading, and in this section we are going to discuss 2 more parameters. Everyone should be well familiar with these parameters, but I'm not sure everyone understands this correctly. In general, when someone asks the characteristics of an ideal op-amp, these 2 parameters comes as first. First one is input impedance, second one is output impedance. Based on Ohm's law, where I is equal to V by R, it could be easily understood that current and resistance are inversely proportional. When resistance increases, current decreases. When resistance decreases, the current increases. Let us consider an example. Here we have 2 power supplies, power supply 1 and power supply 2. Both of these power supply are capable of generating 5 volts. But the difference is, the first power supply is capable of generating 5 volts at 1 amps rated current, and power supply 2 is capable of generating 5 volts at 0.1 amps rated current. Now you tell me, are these both power supplies same? Their output voltage is 5 volts, but the rated output current is not same. One of these power supply is having a high output current and the second power supply is having a low output current. In that case, we could tell that the output impedance of the power supply 1 is lower than the output impedance of the power supply 2. If you consider that a source have high output impedance, it means it can drive only less amount of current. If you tell that the power supply has lower output impedance, it means it can drive a large amount of current. Now let us take another example. We have a bulb A and a bulb B. Both of these bulbs are operated at 5 volts. So when you connect 5 volts, 2 of these bulbs are going to glow. But the difference is, bulb A will consume only 10 milliamps of current and bulb B consumes 1 milliamps of current. In this case, both of these bulbs are operated at 5 volts, but the current consumption of these bulbs are different. Since the current consumption of bulb A is lower than bulb B, it could be said that bulb A is having lower input impedance than bulb B. When you tell a circuit has a very high input impedance, it means that the circuit will get very less amount of current in order to operate. If you tell a circuit has a lower input impedance, it means the circuit requires more amount of current in order to operate. I hope you're clear with input and output impedance of a circuit. Some source will have very high output impedance, which means it can drive only smaller loads, it cannot drive a large amount of current. For example, let us take a passive temperature sensor. But wait, is this temperature sensor a power source? Based on the definition of the source, anything that produces an electrical energy is a source. So basically a sensor produces an output voltage which is based on the parameter it is sensing. For example, let us consider a passive thermal sensor. So the output voltage of this thermal sensor will be a function of the temperature it is monitoring. Usually these passive sensors are capable of sourcing only few hundreds of nanoamperes of current, which is very less. So when you are actually trying to connect this sensor to another circuit or an analog to digital converter, which could have a considerably higher amount of current consumption, the output voltage of this sensor tend to drop because of overcurrent loading. So we tend to lose our signal. As we all know, op-amps have very high input impedance, which means it consumes very less amount of current from its input. So when you connect the sensor to the op-amp, it consumes very little amount of current and the sensors will not be overloaded. So the output voltage of the sensors will not be corrupted. As we see on the other side of the op-amp, where it have a very low output impedance, which means op amp will be able to drive some higher amount of current load. As we have already seen that this passive thermal sensors can only source up to a few hundred nanoamperes of current. But when you connect it to a unity gain amplifier, the output of the amplifier would be able to provide a higher current, like in the order of tens of milliamperes of current. It has to be understood that the current from the thermal sensor is not being amplified. If I try to put it on the other way, the drive strength of this passive sensor is being increased with the help of an operational amplifier circuit. So that is why we use unity gain amplifiers in our circuit. I hope this video has been useful to you. Let me know by hitting the like button. Share this with your friends, and if you have any question or suggestions, put them in the comment box. Subscribe to EMI Labs if you haven't already subscribed to it. I will see you in another video. Until then, it's bye from Suresh Surya.